Welcome to Get Your FRQ On. This question is from 2014. It's question 4, and it is not calculator active. In the question stem, we have a table of values for train A at different times t, and the values of a differentiable function for the velocity of train A, measured in meters per minute at those times. In part A of the question, we are asked to find the average acceleration of train A over the interval from t equals 2 to t equals 8 minutes. To do this, we can use the formula for the average rate of change. V sub A of 8 minus V sub A of 2 all over 8 minus 2 is equal to negative 120 minus 100 all over 6. This simplifies to negative 110 over 3. And don't forget the units. So the average acceleration of train A from t equals 2 to t equals 8 minutes is negative 110 over 3 meters per minute per minute. In part B of the question, we are asked if the velocity of train A ever equals negative 100 meters per minute for some value of t between 5 and 8 minutes. Since v sub a of t is a differentiable function, v sub a of t is also a continuous function. The average acceleration of train A over the interval from 5 to 8 minutes can be found using the formula for the average rate of change. We have v sub a of 5 equal to 40, v sub a of 8 equal to negative 120. Since negative 100 is between v sub a of 5 and v sub a of 8, there must be a value of t between 5 and 8 where the velocity of train A is minus 100 meters per minute. In part C of this question, we are given that at t equals 2 minutes, s of t is 300, and v of 2 is greater than 0. We are asked to write an integral to find s of t. Then we are asked to use 3 trapezoids to approximate the value of the definite integral and find s of 12. The position function, s of t, is equal to 300 plus the integral from 2 to t of v sub a of x dx. So s of 12 is equal to 300 plus the integral from 2 to 12 of v sub a of x dx. Using 3 trapezoids as instructed, we get 300 plus 3 halves of 140 plus 3 halves of negative 80 plus 4 halves of negative 270. We conclude that s of 12 is equal to 300 minus 450, which is negative 150 meters. In part D of the question, we have a second train, train B, whose velocity is given by the function v sub b of t equals negative 5t squared plus 60t plus 25. We are also given that s of 2 for train B is 400. We are asked to find the rate at which the distance between trains A and B is changing at t equals 2 minutes. Let z equal the distance between trains A and B. We are given that s sub a of 2 is equal to 300 earlier in the problem. And in this part of the problem, we are given that s sub b of 2 is equal to 400. So let x equal s sub a of t and y equal s sub b of t. Then we get the equation x squared plus y squared equals z squared. That comes from the Pythagorean theorem. This implies that 2x dx dt plus 2y dy dt is equal to 2z dz dt. And substituting in known values, we get 2 times 300 times 100 plus 2 times 400 times v sub b of 2 equals 2 times 500 times dz dt. Finding and using v sub b of 2 to solve for dz dt, we get 60,000 plus 800 times 125 all over 1,000 meters per minute. If you want more AP Calculus AB free response solutions, don't forget to like my videos and subscribe to my channel. You can also follow me on X at Get Your FRQ On.